This is AS3 2009 question 4. On the axis of figure 4.1, sketch a graph showing how the intensity response of the human ear varies with frequency. Label the vertical axis of your graph with appropriate numerical values. So we'll mark in, first of all, along our x-axis here, we'll mark in the key places. So 20 Hertz, your minimum hearing frequency, and then 20,000. And then you know that your minimum threshold happens at about 2,000, which we'll say is about there. And you know that happens at 10 to the minus 12. So if this was 10 to the minus 12, what would that look like? 10 to the minus 12, minus 10, minus 8, minus 6, minus 4, minus 2, 0. Sorry, that's 1, I mean. And then it goes on up to 10 to the 2. So that would be fine. So it's 10 to the minus 12, 10 to the minus 10, 10 to the minus 8, 10 to the minus 6, 10 to the minus 4, 10 to the minus 2, and then the next one would be 1, and the next one would be 10 to the 2. And so you know that this starts at 20 Hertz there and goes down to here at 10 to the minus 12, and then, sorry you can't see that, and then at 2,000 Hertz, which is here, it goes up to about 10 to the minus 2, which is about there. And we're just going to join those points up. And then it doesn't say to shade in, but we're that used to doing it, we'll just do it anyway. So we'll just shade in what you can actually hear, and you hear everything in that region there. So not only do you have to know these key points, but also it's very helpful if you know what the log scale actually does, and it goes from 10 to the minus 2 to 1 up to 10 to the 2. So just be on your thinking on your feet about that. State 2 effects of excessive noise in humans. We've had this before as well. So obviously hearing loss is the biggest problem. So hearing loss or hearing damage or pain in the ears. And then other effects that you could have there are things like digestive problems, nervous problems, lack of concentration. So learn 2 or 3 of these and you'll always have a few that you can say. Next, state the minimum value of sound intensity level that constitutes excessive noise for humans, and that's 85 decibels or greater. So that's 85 decibels. And then the last part of the question, it is possible to buy additions to headphones that reduce background noise, for example traffic, so that the listener does not hear traffic noise with the music. Suggest one reason why these additions are encouraged by societies for the deaf and hard of hearing, and one reason why they might be discouraged by road safety bodies. So the Society for the Deaf would suggest these so that you would have lower music levels that you're listening to, and therefore less hearing damage. But the road safety, obviously the problem is that drivers have to be able to hear everything that's going on. Drivers need to hear all noise. To warn of dangers. So that's a very straightforward thing. You really wouldn't have had to study any physics to come up with something like that.